especially for Nick and Z. Today we are going to learn about a redox reaction by half reaction method. So let's start with the example how to balance redox reaction by half reaction method. As for example, suppose they are given that FeS2 plus FeS2 plus O2 gives Fe2O3 plus SO2 plus H2O. Now, according to step 1, first calculate oxidation number of each elements. Calculate oxidation number. Again write this equation, FeS2 plus O2 gives Fe2O3 plus SO2 plus H2O. Now oxidation number of Fe, that is plus sulfur is having -2, each sulfur having -2. So first I will write -2. Now 2 2s are 4. Fe having +4. Dioxygen free element available in nature. That's why 0. Each oxygen with -2. -2 3s are -6. So put here +6 to make it 0. +6 divided by 2. So Fe having +3 oxidation state in this particular compound. Each oxygen having -2, 2 2s are 4. Then sulfur having +4. Hydrogen +1 and oxygen -2. So first you have to calculate oxidation number of each single element present in particular reactant side or product side in each component or molecule. Now first you remove that oxidation number of spectator ion. Here you find that particular this oxygen, no change with the oxidation number, so remove out -2, -2. Now step 2, that is balance reaction. Here balance reaction accept hydrogen and oxygen according to oxidation number method. But if change in oxidation number of oxygen or hydrogen, that in a particular manner in this component only you have to balance that oxygen or hydrogen like this. Again I write this equation that FeS2 plus O2 gives Fe2O3 plus SO2 plus H2O. Now here 1 Fe, 2 Fe, so multiply with 2. So iron Fe balanced. Sulfur 2 2s are 4. So I put here 4. So sulfur also balanced. Now total number of oxygen doesn't count both of sides. You can say that this oxygen with 0 oxidation state change with the -2 in these two components. So you can make a balance of oxygen in O2 as well as H2O. Here 2 oxygen, so put here 2 to make it balance of particular oxygen in this component only. Don't count this oxygen, because one more additional step we will take for the balance of oxygen. So particular, remember in the step 2, if change in oxidation number of oxygen as well as hydrogen in particular component, that component only balance with oxygen or hydrogen. That you understood very well. So I will make a balance this oxygen with 2. Here also multiply with 2 to make it balance the oxygen, not a total number of oxygen. Hydrogen is not here, so no need to balance hydrogen. That you understood very well. Now again multiply this oxidation number with the number of atom present in this each component. So here the rough work you will make in earlier step. So final step you will get a perfect value. Here 2Fe, so multiply this oxidation number 4 with 2. So 4 2s are 8. You will take plus 8. Here sulfur 2 2s are 4 atom. So multiply 2 with 4. You will obtain minus 8. Addition of this both. So you will obtain plus 8 minus 8. Total change or total oxidation number of this compound becomes 0. Now 2 multiply with 0, you will obtain that is 0 only. Now that 2Fe, so plus 3 multiply with 2, then you obtain plus 6. Oxygen, spectatus ion, no change in oxidation number, remove it. Sulfur 4, so 4 into 4, that obtain plus 16. Addition of this both, because Fe and S both addition we will take, so plus 16 plus 6 you will take plus 22. Here 2 oxygen is there, multiply this oxidation number with 2 atom, you will obtain 2 2s are 4 minus 4. So dear student, here you easily understood that how first we calculate only the single atom before balance equation, oxidation number of single atom expressed, and then after balance reaction or balance each element, we just multiply number of atom with oxidation number of one atom and get a final oxidation number. That you understood. Now step 3. Step 3, that we find split half reaction, oxidation half reaction and reduction half reaction according to change in oxidation number. So split oxidation half reaction and reduction half reaction according to increase oxidation number or decrease oxidation number. You can understood with this that oxidation half reaction is reaction in which oxidation number increases. Here you find that 0 to plus 22, 0 to plus 22. You can easily understood that oxidation number of FeS2 increases in Fe2O3 plus 4SO2. So we split this equation as oxidation half reaction. So I will write here twice FeS2 gives Fe2O3 plus 4SO2. I will consider that is oxidation half reaction. Similarly, reduction half reaction. As you know that oxidation number decreases in which half reaction from reactant to product, you will consider that is reduction half reaction. You can easily understood that oxidation number of dioxygen decreases from 0 to minus 4, 0 to minus 4 in this reactant to product. I will consider it is reduction half reaction. So write like this: O2 gives twice H2O, Here you easily understood that O2 convert into twice H2O, then its oxidation number decreases from 0 to -4. Sometimes what happened, they are not given this H2O, so in this step you have to write H2O and balance with O2. So sometimes in many reaction or exam I show this that H2O is not given product side, so you have to write by your side, and finally it may balance or it will remove in net reaction. Now you can understood how to split this oxidation as well as reduction half reaction, and also you express that change in oxidation number. Here you find that change in oxidation number 0 to plus 22, and here that 0 to -4. So here you will find that decrease in oxidation number, here increase in oxidation number. So it is oxidation half reaction and it is reduction half reaction. That you understood very well. Now next step. Now step 4. Step 4, that balance charge. Balance charge in both of half reaction, oxidation half reaction as well as reduction half reaction. So first rough work, then you have to calculate charge of both of reaction in both of side, react as well as product side. So here you will find that rough work take in earlier step. So here total charge 0, 0 plus 0, total charge 0. In this reduction half reaction also you find that 0 charge here, 0 charge here. So no need to make a balance because charge is already balanced. Sometimes they are given acidic medium or basic medium and charge is present in any one of the side. So you make balance this charge with the help of H plus in acidic medium as well as OH minus in basic medium. This type of different example later on we will take, and that you understood. But here total charge in both of half reaction becomes 0, means already balanced. I will write or carry forward this reaction only. Oxidation half reaction, that is twice FeH2 gives Fe2O3 plus 4SO2. Reduction half reaction, that is RHR O2 gives twice H2O, that is balanced with charge. Now step 5. In step 5, add electrons. According to change in oxidation number. Now you find that here change in oxidation number 22. So you have to write plus 22 electron or 22 electrons in right side, because during oxidation half reaction electrons are loose or electrons are even. So oxidation half reaction twice FeH2 gives Fe2O3 plus 4SO2 plus 22 electrons. I have had 22 electrons product side because during oxidation half reaction electrons are even. That you understood according to definition. Now that in reduction half reaction RHR, reduction half reaction, change in oxidation number 4. So 4 electrons add in reactant side, because in reduction half reaction electrons are gained, electrons are added. So O2 plus 4 electron gives twice H2O. So add electron according to change in oxidation number. Here 22 change in oxidation number in oxidation half reaction. So 22 electrons add in oxidation half reaction, product side. Similarly, 4 change in oxidation number or decreases oxidation number, hence 4 electrons are added in reactant side in reduction half reaction. That you understood very well. Now in step 6, that make number of electrons equal, make number of electrons equal. To make it equal number of electrons is necessary, because in net reaction electrons are not present, so it is necessary that electrons are cancelled out from both of half reaction, and that's why it is necessary to number of electrons in both of half reaction becomes equal, and that's why I will multiply here 22 2s are 44, so multiply with 2, and this reaction multiply with 11, so 11 4s are 44 and 22 2s are 44. So whole half reaction, oxidation half reaction multiply with 2, reduction half reaction multiply with 11, and then oxidation half reaction OHR multiply with 2, so 2 2s are 4, FeS2 gives 2 Fe2O3 plus 4 2s are 8 SO2 plus 44 electrons. 22 2s are 44 electrons. That you understood very well. Similarly, reduction half reaction RHR, that is multiply with 11 O2 plus 44 electrons gives 11 2s are 22 H2O. That you understood very well. Now step 7. In the step 7, balance oxygen. I asked in earlier step 2 that further we equal that total number of oxygen in both of half reaction as well as both of side, and that's why that only particular component in which change in oxidation number of oxygen it make a balance in step 2. Now total number of oxygen balance in this step. So first you calculate oxygen or number of oxygen in both of half reaction, in both the side, reactant side as well as product side. Here you find that 0 oxygen, here 3 2s are 6 plus 8 2s are 16, 16 plus 6 total 22 electrons present in oxidation half reaction and product side. Rough work I will make in earlier step. Here also you calculate that here 11 2s are 22 oxygen, here 22 oxygen. So here you can find that oxygen is balanced in both of sides. So I will write in this step that balance oxygen, that in reduction half reaction it is already balanced. So I will write as it is 11 O2 plus 44 electrons gives 22 H2O. Now here how much lack of oxygen in which side use H2O to make it balance. Here 0 oxygen, and that's why I will write plus 22 H2O added at reactant side to make a balance of oxygen in both of side in oxidation half reaction. So I will write 22 H2O plus 4 FeS2 gives 2 Fe2O3 plus 8 SO2 plus 44 electrons. So in this step, I will make a balance of oxygen in both of half reaction, in both of side, reactant side as well as product side, oxidation half reaction as well as in reduction half reaction. Now in step 8, add both of reaction. Both of half reaction, take addition or sum total, add both the half reaction. Here you find that oxidation half reaction, that is 22 H2O plus 4 FeS2 gives twice Fe2O3 plus 8 SO2 plus 44 electrons. Now in reduction half reaction, that 11 O2 plus 44 electrons gives 22 H2O. Now take addition, we will get a net Redox reaction, that is, here you find 44 electron cancel out, 22 H2O. If they are given, it will remove. Not given, you added here in step 2, then you easily understood it will cancel out. So finally you will get balanced redox reaction, that 4 FeS2 plus 11 O2 gives twice Fe2O3 plus 8 SO2, that you find, that is your balanced reaction. Here you can calculate the number of hydrogen in both of sides. If it is balanced, then your reaction becomes balanced. Here 0 hydrogen is there, here 0 hydrogen is there. So you can understood that number of hydrogen is balanced in both of sides, your reaction becomes balanced. Then also further you will check with the table that how this balance is occur, or balance or not, you will check and give your answer. Asked in MCQ that how much number of oxygen are balanced, how much charge is balanced, how much oxidation number are changed, how much electrons are balanced. And suppose this type of many questions along with half reaction, you can easily solve with the table. So I will make one table according to balance reaction, and that you understood. So let's go with summary table according to balance equation. In first column we will write that elements. Here elements present Fe, that sulfur, that oxygen, hydrogen is not present. Then also we will write here hydrogen, because in earlier case H2O is given. Charge, then number of electrons which cancel out, then OHR oxidation half reaction and RHR reduction half reaction, change with oxidation number. Then finally you will consider that any other what they ask, that how much electrons are added, or you know that how much H2 is cancel out. So number of H2O, or H plus or whatever additional information they have to ask, you will write in this special column. Now here that reactant side, and here product. Number of Fe you will find here 4 Fe, that reactant side, product side, 2 2s are 4 Fe. So you can say that equation is balanced in terms of iron Fe, first element. Now sulfur, 4 2s are 8 in reactant side. Similarly product side you will find 8 sulfur is present. So sulfur is also balanced. Now oxygen, 11 2s are 22 at reactant side. 22 oxygen is present. Here you find that 3 2s are 6 plus 8 2s are 16. Total 22 oxygens are present in net reaction in both of side, reactant as well as product side. Now hydrogen, 0 hydrogen in both of sides, so hydrogen 0, it is also balanced or not present. Charge, you will find that total charge of reactant 0, product 0, so charge both of sides 0. Number of electrons are not present in net reaction, but how much cancel out? I will make two columns, that 0 electrons, 0 he necessary or 0 is must in net reaction, because in balanced redox reaction electrons are not present. But how much cancel out? So you have to express that cancelled electron, that 44 and here 44, both of it side 44 electrons cancel out. You can write from this addition reaction. Now the change in oxidation number in oxidation half reaction, that is 22 increase and 4 decrease. You can understood with the earlier step. Now number of H2O cancel out, or some spectator ion is present, you have to add or you have to remove in earlier step. You have mentioned here 22 H2O present or cancel out from reactant side as well as product side, 22 H2O. So with the help of this table you can able to answer easily from the given MCQ that how much number of H2O cancel out, how much electron are equal and cancel out in both of half reaction, how much electrons are added to make it a balance in the step 6. So here you can write that in oxidation half reaction you have to put 22 electrons and in this 4 electrons. So that you can answer with the change in oxidation number, that 22 electrons here and 4 electrons here. 22 electrons in right side in OHR, while in 4 electrons in left side or reactant side in RHR. So this type of question you can easily solve with the table. So you make a table from this balanced equation and that's you can easily give the answer of this type of MCQ. So dear student, you can easily understood how to solve your redox reaction with the help of half reaction method, which is only the based on oxidation number method, because in this method we have to use oxidation number or change in oxidation number, and according to this electron exchange or put electron according to change in oxidation number in both the half reaction, oxidation half reaction as well as reduction half reaction. So you can understood very well how to make a summary table, and with the help of this summary table you can easily answer your MCQ. In next episode we meet with the other example. Everybody good day.